Who knows that you are watching this video? If you look up here somewhere, the web address of this video starts HTTPS, and the S implies that this web experience for you is secure. In practical terms, what that means is the internet traffic between your computer and YouTube's computer only makes sense at two places on the planet: on your computer and on YouTube's computer. In between those 2 points, the internet traffic is gibberish. And here's how that is set up. The way this works is with what's called a shared secret. Your computer and YouTube's computer have to come up with a number that they both know, but that nobody else in the middle could possibly know. And it works with something called clock arithmetic. And clock arithmetic just means you divide by the clock size and take the remainder. Now, why is that good for encrypting internet traffic? Because as a mathematical function, it's one way. You can easily figure out an answer, but there's no easy way to go back to get the question. If we take, as an example, clock size 12, which is the size of my clock here, and we feed the number 13 into it. 13 divided by 12 leaves a remainder of 1. But 25 divided by 12 also leaves a remainder of 1. 49 divided by 12 leaves a remainder of 1. So knowing the answer 1 does not help you get back to the number that was fed in. So here we have one computer communicating with the other. What happens is each of them come up with a private number. So over here we've come up with the private number 5. And one of the computers comes up with a number that we'll call the base, and another number that is the clock size. And it advertises those two publicly. In other words, it sends them to the other computer. So here we have base 3 and clock size 12. So this computer has sent those to this computer. Then what we do is we take the base and we raise it to the power of the private number and divide it by the clock size and take the remainder. So here with private number 5, when you do that, 243 divided by 12 gives you a remainder of 3. And that number is publicly sent to the other computer. This other computer does exactly the same thing. It's come up with a private number 4. 3 is the base. 3 to the power 4, clock size 12, gives you 81 divided by 12, remainder 9. So it sends the number 9 to the first computer. And then the two computers do a calculation using those two publicly shared numbers to come up with the shared secret. And the way you do that, you take the other computer's shared number and raise it to your private number. So 9 to the power 5, clock size 12, which gives you, and I did it on a calculator obviously, 59,049 divided by 12 gives you a remainder of 9. So that is the shared secret. And if the other computer does the same calculation, they should also end up with the same answer, 9. So they were shared the number 3. 3 to the power 4, which is the private number of the second computer, clock size 12, gives you 81 divided by 12, and that gives you a remainder of 9. So this computer ends up with the answer 9, and this computer ends up with the answer 9. And then having done that, all that the computer does is every chunk of message that gets sent from one computer to the other computer has that number 9, added to it. And then the other computer just has to take it away to get the sensible message. Now the numbers that are used in reality are much bigger than this. The size of the numbers are like the number of grains of sand on 1,000,000 planet Earths covered in desert. And why is this of interest to social science? It's because the answer to the original question, who else knows you are watching this, is not dependent just on the numbers. There's more to it than that. So is that the end of it? Well, no, it's not. There are a couple of caveats here. The first is that while mathematically this system might be perfect, the implementation need not be. So the person who's implemented HTTPS might have screwed up. The second point to note is that government agencies are actively trying to undermine, or at least have been in the past, actively trying to undermine security and encryption. And they might have managed to weaken this encryption somehow in ways that we don't yet know. And the third point to note is that this internet traffic makes sense on your computer and on YouTube's computer, so Google know that you've been watching this video, and potentially they could be served a warrant and be required to hand that information over at some point in the future. And even that is not the end of it, because the internet traffic makes sense on your computer. So where are you when you're watching this video? Could it be that there's somebody standing over your shoulder looking at what you're doing, which is actually the most likely way that your security could be compromised? Or perhaps you're in a place where there's a camera on the wall and they could zoom in on your computer screen and see what you're watching. If you're not using your own computer, and possibly even if you are, it could be that someone has installed keystroke capture software and is recording what you're typing in, and would therefore know that your computer had been used to access this video. And there it is, HTTPS. Subscribe down here somewhere if you like these videos.